Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Khalil Rahimullah. So this is my paper. This is my Isas. The title is CPU scheduling on Windows 10. So this is my PowerPoint. I'm gonna show you my presentations. Okay. Like I said before, my paper's title is CPU scheduling on Windows 10. This is a presentation from group 7. The background is, scheduling is a key concept in multitasking, multiprocessor operating system, and real-time. Operating system scheduling is the way or method of various processes executed on the CPU, where there are usually more processes running than the number of CPUs available. It is managed by scheduler and dispatcher of software. The purpose of multiprogramming is to have a number of processes running at all times to maximize CPU usage. The purpose of time division is to replace the CPU and processes so frequently that the user can interact with each program while the CPU is running per uniprocessor system. There will be no more than one process running. If there are more processes than that, the others will have to wait until CPU free and can be rescheduled. So this is my table of content. In these presentations, we're gonna discuss about the first is the definition, second is basic concept, the third is theory, the fourth is implementation, and the fifth is conclusions and suggestions. Okay, the first one is definitions about Windows 10 and CPU scheduling. Windows 10 is a personal computer operating system developed by Microsoft as part of the Windows NT family of operating systems, introduced on September 30, 2014, released on July 29, 2015, and in November 2015. Threshold 2 of Windows 10 was released to the public, first introduced in April 2014 at the Build Conference. Windows 10 aims to address deficiencies in the user interface, first introduced by Windows 8 by adding additional mechanisms designed to enhance the user experience for devices without touch screen, such as the desktop computer and laptop, including the revival of the Start menu seen in Windows 7 Virtual Desktop System and the ability to run Windows Store application in Windows on the desktop rather than full screen mode. The definitions about CPU scheduling. CPU scheduling is a process which allows one process to use the CPU while the execution of another process is on hold in waiting state due to unavailability of any resources like E or O or etc. Thereby making full use of CPU. The aim of CPU scheduling is to make the system efficient, fast, and fair. Whenever the CPU becomes idle, the operating system must select one of the processes in the ready queue to be executed. The selection process is carried out by the short-term scheduler or CPU scheduler. The scheduler selects from among the processes in the memory that are ready to execute and allocates the CPU to one of them. The basic concept of CPU scheduling. In a multi-programming system, there are always several processes running at one time. Whereas is uniprogram, this will not happen because there is only one process running at any given time. A multi-programming system is needed to maximize CPU utility. We can see the picture. This is a process. This is a basic concept of CPU scheduling. How CPU scheduler this program. We can see this picture. And when the process is executed, the CPU's execution cycle, of course, waits for I or O, which is called the CPU I or O. Burst cycle, process execution starts with a CPU burst and continues with an I or O burst, followed by another CPU burst, then another I or O burst, and so on. The third is theory of CPU scheduling. CPU scheduler. When the CPU is idle, the operating system must select the processes in main memory ready to be executed and allocated CPU for one of these processes. This kind of selection is called the short-term scheduler. CPU scheduler, the decision to schedule to the CPU follows for circumstance. This is how the scheduler in CPU. When the process moves from a state of running to waiting, that is a first scheduler. When the process moves from running to ready, when the process moves from waiting to ready, and lastly, when the process stops. If the selected scheduling models uses condition 1 and 4, that is, then this kind of scheduling is called non-preemptive. Conversely, if it's 2 and 3, it is called preemptive. In non-preemptive, if a process is using the CPU, it will still carry the CPU until the process releases it, stops, or is in a waiting state. Preemptive scheduling has a weakness, namely the cost required is very high among other things. Data improvement must always be done. This happens when a process is abandoned and another process will be carried out immediately. So, the second theory is scheduling criteria. In CPU scheduler, we have scheduling criteria to running the program. The different CPU scheduling algorithms will have different properties. There are several criteria used to compare CPU scheduling algorithms, including the first one is CPU utilizations. It is accepted that the CPU is always busy. CPU utilities are expressed in the percentage terms, namely 0 until 100%. However, in reality, it only ranges for 40 until 90%. Throughput is the number of processes that have been done in 1 unit of time. Turnaround time, the amount of time it takes to execute a process from starting to wait for a place in main memory, waiting in ready while executing by the CPU and doing I or O. Waiting time, the time it takes for a process to wait in the ready queue. This waiting time does not affect process execution and I for O usage. Response time, the time it takes for a process from asking to be served until there is a first response in response to the request. Fairness, ensure that each process will receive a fair share of CPU usage time. Dispatcher. The dispatcher is a model that will be control over the CPU for the selection of processes performed during short-term scheduling. The function contained therein include switching context, switching to user mode, jump to a specified location in the user program to start the program. The time it takes a dispatcher to stop one process and start another is called the dispatch latency. Process scheduling algorithms. This is all of process scheduling algorithm in CPU scheduler. So there is round robin scheduling, or RR, you can call RR, FIFO scheduling, FIFO priority scheduling, PS scheduling shortest advanced, SGF scheduling with multiple queues, MVQ scheduling with the shortest remaining time priority, SRF highest response rate priority, HRN scheduling, guarantee scheduling, KS. So this is the process scheduling algorithms in CPU scheduler. In this presentation, we'll not discuss about what is a round robin scheduler, what is a round robin scheduling, and what is the algorithm on round robin scheduling. This is just type of process in CPU scheduling. So how to implementations? When we open an application on a computer, there is a CPU scheduling process that runs automatically according to the way of working that has been described in the theory above. But CPU scheduling works at the command of the user who runs the computer. When the user opens applications, CPU scheduling processes occurs the user's command. The picture above is an example of CPU usage used by the user where there is CPU scheduling. So we cannot control all of CPU scheduler work, but we can give a command to CPU scheduler. We can give some suggestions or permissions for CPU scheduler. When we turn on our computer, there is a CPU scheduling process that has been set by default by your respective computer. We can stop on off the programs by doing an test. But we must pay attention to the program, whether the program is the core of program of the computer. If so, then it is very dangerous for us to end the test. So we have to be careful when we want to end test some program, because if the program is a core in the CPU or in the CPU on your computer, I think that's gonna be a problem in your computer, because the core of computer is very important. From the test manager application, we can see the CPU work on our computer. So the simple things is that when we open one application to another, that's when the scheduler CPU process occurs. So the conclusion and suggestions is: conclusions. In a computer, there is a system that regulates the running of an application and processes the application to run, namely CPU scheduling. When we turn on the computer, the process runs automatically, but the process will run because a user controls the running of the applications. Suggestions: to see the performance of our CPU that has been processed by CPU scheduling, it would be nice when we open the application while looking at the task manager. To find out how CPU scheduling works and to find out how to CPU ability on our computers, to open the applications. Thank you for listening my presentations. So I hope you enjoy this paper. Thank you. Assalamualaikum warahmatullahi wabarakatuh.